Good afternoon, everyone. Welcome to Tutors. Now, this is the fourth video in our series of magnetic method qualitative analysis, and here's an example we are going to evaluate and also interpret qualitatively. Now, the following questions are being asked about this residual anomaly gotten data. Okay, so say by using any suitable method, which means you can either use the theta half slope method we've used before or the half weight method we've used in the previous video to find the depth, to estimate the depth to the causative body of the anomaly present in the table below. So this is the data, the x, the distance is on the x-axis, theta t is on the y-axis. So we're going to plot, after plotting our data, you can see, so we plot our data, join them together. Okay, okay. So we are joining all our plot together. Good. So now we've plotted our graph. Now the next thing is to find the depth to the estimates of the body. So we can either use the half width method or the Peter slope method. So for this, I'm just going to use the Peter slope method. We use Peter slope method. Now for the Peter slope method, I told the Peter slope method, we look at the point of inflection. So this is the point of inflection here, right? This is a point of inflection, and this is another point of what? Another point of inflection, right? So we are going to ensure that they are parallel to each other. They are what? Parallel. I'm going to rule that line and do this again for this guy. Ensure they are parallel. Can you see that? So they are parallel. So from there, you can then rule a line either up there because there's no space here. That's why I didn't want to just do it here. Just come here and join them together. So they are parallel. And this will become your x. Okay, so now I told you about counting. You take the first line as 0, then the increment. So since this is on the increment on our x-axis, rising to 70 representing 20 unit, Abby. So which means each is increasing by what? 2. Each line increase. So each small line. Here is 0. Here is what? 2, 4, 6, 8, 2. So this one too. You start from here at 0. And yes, we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So we say our x is equals to 24 meter. So since we've gotten that our d is equals to 24, sorry, x 14, assuming that we have a thin magnetic source. So that's Peter slope. We assume if it's thick, it is thick. So for thin, formula is given as d is equals to 1, sorry, x is equals to 1.2 d, x equals to 1.2 d, and x here is 24 is equals to 1.2 d, 1.2, 1.2, 1.2. We are saying 24 divided by 1.2 is equals to d, then 24 divided by 1.2 is something as 12 over 10, then 10 over 12, then we have 2 over 10, and that's like 24 times 10 over 12, and 20, and d is equals to what? 20 meter. So we estimated the depth to the source. Okay, so you can try the half width method on it. You're welcome. Now, the next question is name a classic geologic method, geologic feature. So what feature could produce anomaly? So a feature that could produce this kind of anomaly is known as a contact. It's just an estimate. We're just trying to just, so it's a contact. You can see the way it looks like a typical picture. Looking at giving a fault. So the answer here is a contact, for example, a fault. Now the next one says sketch the geologic feature beneath the anomaly. Sketch the geologic feature beneath the anomaly. So you take a ruler, you rule a line here, okay? You rule a line here. Then beneath it, you can either draw something like this, two arrow. They are going to show a fault because they are going to show displacement of blocks. Or you draw the blocks for real. You draw the blocks and you put the arrow there. Okay? Can you see that? Good. Now they say, what simple geometric shape can the geologic feature be approximated to? What simple geometric shape can the geologic feature be approximated to? The simple geometric shape is the um, vertical thin sheet, the vertical sheet, a vertical sheet. Can compare to a sheet, it's thin. Compared to a sheet, a vertical sheet. Okay, vertical sheet. Now that's the end to our video. So thank you very much for listening. In my next video, we are going to cover some questions on the magnetic, and we're going to use the half-weight method, solving the residual anomaly for it.